Muhammad Inzamam. Hope you are liking and subscribing all the videos. Share with your friends. If you haven't subscribed so far, go press the subscribe button, press the bell icon guys to be notified for the further more videos. Definitely this is going to be utilized for your TSC ECET examination. Plan well for your ECET examination guys. Thank you very much. This is Muhammad Inzamam signing off. Thank you very much guys. Hi, welcome back everyone. This is Muhammad Inzamam. Let's continue our physics topic of part 2, that is collisions concept guys. In this part we are going to discuss about collisions, type of collisions, elastic, inelastic, who's having the more probability of damaging elastic collision or inelastic collision, formulas, coefficient of restitution, then what is the range of the coefficient of restitution relation to that of the kinetic energy, standard values, and how much amount of fraction of energy is going to be lost due to the coefficient of resistance. Let's start the topic guys. The first topic which we are going to discuss is collisions. Try and remember all the important cases of the collisions by a graphical representation. Let's say collisions are of three types. When the bodies are going to collide with each other guys, momentum transfer will take place, kinetic energy transfer will take place. Let's see how these are going to transfer from one body to another body. Types of collisions guys, in the first type of collision is called as elastic collision, and the second one is partial inelastic collision, and the third one is inelastic collision. You can understand it very clearly guys. Let's say it is having a fixed support, you are having a fixed one, and the body is coming and touching this one, and again the body is going to travel in the different direction. Let's say it's having some velocity, it's having a mass, let's say it is equals to some velocity v1, and let's say it's having the velocity v2, and in this case of elastic collision v2 is equal to v1. V2 is equals to V1 means what guys? Kinetic energy is conserved. There is no drop in the kinetic energy, no lost in energy, guys. And we haven't even going to hear any sound. That is no sound, no collision sound, no sound in collision. That means no loss of energy, total energy conservation is going to happen. Now let's talk about the partial inelastic guys. Partial inelastic is an example where we can hear the sound. It's a practical one. It's a practical application where a body is going to be moving in the other direction. Let's say it's having v1 velocity, let's say it's having v2 velocity, and v1 is not equal to v2 because a small amount of energy is going to loss. Energy loss is going to be takes place. Let's say this is a sound is going to be there guys, striking sound striking, sound in a strike. That means a small amount of a little bit of energy is going to be absorbed or is going to get lost. Small energy lost, we can say. You can tell in the partial inelastic. Last one is what guys? Inelastic collision. Inelastic collision is, let's say this is the substance of having a velocity v1, and once it is going to struck here, it is going to be sticking to the surface. That means initial velocity is equals to some v, but final velocity will be equal to 0. It is going to totally sticking the surface. Whereas in these two cases guys, it is going to bounce. It is going to bounce. So now it's very clear to understand about the collisions guys, elastic, partially inelastic, and inelastic collision. In the elastic collision, body is going to bounce. In partially inelastic also, body is going to get bounced. It's it won't stick guys. Then here total energy is going to be conserved. Kinetic energy is going to be conserved guys. No loss of the energy, no sound in collision, bounce. That means total amount of energy is going to be converting from one form to another form. Partially inelastic, a little bit of energy is going to get lost. Inelastic collision guys, the body is directly going to stick there, and the total final velocity of this body is going to become 0. So now we know about the types of collisions. Pause the video and note it down guys. Let's continue guys, that is elastic collision and inelastic collision. Elastic collision states that kinetic energy is totally going to conserve. Kinetic energy is conserved, and momentum is also going to get conserved. The question here given is, what is more damaging when we are going to design this by means of for what guys? Vehicles. that is automobiles. When we are going to design for the automobiles, guys, whether the automobiles are made to be elastic or inelastic. If the body is going to collide, some accident is going to happen, guys, for the automobile or vehicle, which is going to be having what more damage if the vehicle is designed based upon elastic material or inelastic material. Let me give you very straight, guys. It does depends upon which body you want to save inside the vehicle. The person who's saving, you want to save that person, or you want to save that car, guys. Because if the car is made up of an elastic material, that means when it is going to strike there, it is going to bounce back with huge amount of energy, and definitely the greater amount of energy is going to be absorbed by the human body, and the human body is going to fail. Similarly, if the body is going to be designed, that is, the automobile is going to be designed by inelastic material in the sense the body is going to stick down to that accident, and what you can call it as to that bar, to that pole with whom it is going to strike there, and the body is going to deform, and less amount of energy is going to be transmitted to the human body. Let me write it here very straight, guys. Elastic collision, when it is going to happen, automobile does not going to deform well. That is, body, let's say this is an example, guys, and let's try and understand it. Suppose this body is traveling now and it is striking a pole, and it is made up of elastic. Then what's going to happen, guys? It's going to strike and it's going to bounce back. That means greater amount of energy is going to be absorbed by the human body. That is, greater energy is applied over human body. Now let's take the same example for inelastic, guys. Inelastic in the sense it is going to deform. It is going to deform. The car is going to get deformed, guys. Car or whatever the vehicle we are talking about, car is going to deform, and less amount of energy is supplied to human body. But now, in general case, guys, at present all the vehicles are going to be designed on partially elastic and as well as partially inelastic collisions. If the question is asked in the ECET examination or in definite examination, guys, who's having the more damage, elastic collision or an inelastic collision, then your answer must be you want to damage the vehicle or you want to damage the human, guys. Based upon with that one, you are going to answer. Pause the video and note it down. Now let's see the collision formulas, guys, that is given now. That is, collision formulas are classified again based upon elastic and as well as inelastic type of collisions. In elastic collisions, again I am writing the same point that kinetic energy is conserved. Let's say two bodies are there, both are having certain mass and as well as motion. Depends upon the direction, the formula is going to be a little bit changed, guys. Let's say it is M1, let's say it is M2, let's say it is U1, let's say it is U2, and its final velocity is going to become V1 and the final velocity is going to become V2. After the collision and before the collision. Then what is the formula, guys? Momentum conservation and as well as kinetic energy conservation. The first formula what we need to remember, momentum. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. The second formula what we can write in kinetic energy conservation, I am writing, that is half M1 U1 square plus half M2 U2 square is equals to half M1 V1 square plus half M2 V2 square. So how many equations are there, guys? Two equations. How many unknowns? Two unknowns. That is final velocity V1 and the final velocity V2 is what we need to find out. By two equations and two unknown, guys, directly you can calculate the V1 and V2. I am writing the formula here. Try and understand the formula and remember in this manner. Let's write here U1, U2, U1, U2. In all the denominators, you need to write the total masses, guys. M1 plus M2, M1 plus M2, M1 plus M2, M1 plus M2. Focus over it, guys. How to remember the formula? V1, V2, U1, U2, U1, U2. All the denominator total masses, that is M1 plus M2 and so on. The first formula what we are going to write here, M1 minus M2. Here you are going to write M2 minus M1. Here you are going to write what, guys? 2 times of M2. Here you are going to write 2 times of M1. Try and remember the formula, guys. It's very simple. First of all, momentum conservation. Second one is what? Kinetic energy conservation. V1, V2, total masses you have taken here. U1, U2, U1, U2, M1 minus M2. Here you need to write M2 minus M1. 2 times of M2. Here you need to write 2 times of M1. Let's see with the inelastic collision also, guys. In the inelastic collisions, you are having 2 types. When the bodies are traveling in the same direction and the bodies are traveling in the different direction, because we know kinetic energy for the final velocity is going to become 0. So then what is the formula you are going to remember, guys? V is equals to, it's very simple formula, try and remember, guys. M1 U1 plus M2 U2 divided by M1 plus M2. Similarly, another V formula when the both travels in the same direction or opposite direction to each other, the formula is going to become M1 U1 minus M2 U2 divided by M1 plus M2. Pause the video to note it down. Let's continue the topic, guys. The next topic what we need to discuss about is coefficient of restitution. Guys, what is this coefficient of restitution? Let's try and understand. It is the relative velocities. Whenever two bodies are there, they are going to collide with each other, guys. Then what's going to happen? Before colliding and after colliding, how much amount of kinetic energy is going to be restored? That ratio is called as coefficient of restitution. What is given there, guys? Coefficient of restitution is equals to relative velocity. That means change in the velocity. Relative velocity means change in the velocity. Change in the velocity after collision, that is final impact, guys, to the relative velocity before collision. That means how much amount of energy which is going to conserved back. That ratio, that percentage value is talking about is coefficient of restitution. Basically, it is given within the range of 0 to 1, guys. As we all know that 0 to 1 in between the values are similar to that of the percentage values. In that manner itself, if you multiply it with 100, then you can see how much amount of the kinetic energy percentage is restored back. So try and remember, it is values are ranging in between 0 to 1. So it is going to give you how much amount of the kinetic energy is going to restored back after the collision. So relative velocity after collision, relative velocity before collision. So relative velocity after collision, let's say it is V2 minus V1 divided by, you can also write it here in terms of U1 minus U2 or U2 minus U1, because it's anyhow going to become a positive value. I'm writing here U2 minus U1. Let's try and remember the formula, guys. CR is equals to after velocity impact final velocity difference divided by initial velocities difference. Now we know about coefficient of restitution definition. Let's see coefficient of restitution range now. One more time, try and remember, guys. Coefficient of restitution is basically, it's a graphical representation where he is going to give you the values in between 0 to 1. What is the meaning of 0 and what is the meaning of 1, guys? 1 means 100% of energy is going to be restored back. 100% of energy is going to be restored back in which type of collision? Elastic or inelastic collision, guys? Elastic collision. We can write it here, elastic collision, because total kinetic energy is going to be restored. Total kinetic energy is going to be restored. Total kinetic energy is going to be restored. Now 0, that means no kinetic energy is going to be restored. Already we talked about this point that sticking the body's final velocity equals to 0. That means this coefficient of restitution 0 value must be for which type of collisions? Inelastic collision. So now we know about the coefficient of restitution for elastic collision and as well as inelastic collision. Important values, guys, try to remember. CR value is equals to 1, CR value is equals to 0. So now let's talk about the relation to kinetic energy. I already told you that CR is none other than what, guys, related as, CR is related as how much kinetic energy is going to be restored after collision. Kinetic energy restored after collision. This is the point that we need to remember about the kinetic energy. What are the standard values of CR and expected question in the examination is, first of all, a cricket ball, guys. Cricket ball which is going to strike a wooden block. It is going to strike a wooden block. Important one, have to remember what is the value for coefficient of restitution. The value is going to become 0.35. This is the value that you need to remember, guys. Next one is what? A golf ball. A golf ball striking steel block. Striking a steel block. This value is going to become around 0.9, guys. Try to remember these values now. So now we know about the standard values also. Fraction of energy lost. We'll see in the next topic itself, guys. Pause the video and note it down. Let's continue the topic, guys. The last part which we have left out with the coefficient of restitution and collision concept is fraction of energy lost. You can see a diagram over the board that a body is there at a height of h naught. Once it is going to be coming and striking with some fixed target, guys, it's going to be again what bouncing back. This first bounce, second bounce, third, fourth, fifth, sixth bounce. Number of bounces is possible, guys. In each of the bounce, you can see the height has been reduced. Why the height has been reduced, guys? It must be a which type of collision now? It must be a partial inelastic collision, because in the partial inelastic collisions only a little bit of energy is going to get lost and the body is not going to stick to the surface. Given point is, for an object bouncing off a fixed target, then the CR is the ratio of dash. We can write the CR formula as final velocity to that of the original velocity. This is the formula that we need to remember for the CR now, guys, because this is which body now? It is a fixed target, so fixed target does not have any sort of velocities. So we know V can also be written as in terms of root of 2 into G into H. So what is the formula now, guys? CR is equals to root 2G root HF divided by root 2G root H naught. So root 2G gets what? Cancel. So what we can write the formula for CR now in terms of height, guys? HF divided by H naught. Square root is going to the left hand side, it is going to become what? CR square. CR square is equals to HF divided by H naught. As CR square is going to give you how much amount of the energy is restored, then how much amount of the energy lost can be calculated by, let's write the formula, guys. Fraction of energy lost can be written as 1 minus CR square. This is the point that we need to remember. You can also remember this formula in this manner, guys. What is the final height now? Final height formula is also important. Final height is equals to H naught into CR square. H naught into CR square. In some textbook it is given in terms of E also, guys, by the letter E. So that formula also you can remember here. HF is equals to H naught into E square. You can remember in this part. N times, guys, it is bouncing. If the question is asked in such a manner that after some nth bounce, let's say it is first bounce, it is second bounce, it is third bounce. In the third bounce, how much amount of the final height is there? Then you can write in this manner also. HF after n bounce is equals to H naught e to the power of 2n. This is the formula that we need to remember, where n represents what, guys? Nth bounce. These are the all basic important formulas, guys, which you need to remember. Pause the video and note it down. In the work, power, energy concept, guys, we have already discussed about the work and as well as energy. Let's see some basic formulas and important for power. What is the meaning of power, guys? Power is the rate of doing work. Power is the rate of doing work. What we can write for the power formula? Power is equals to work done divided by time. What is the formula for work done? Force into displacement divided by time. What is the formula for displacement in terms of angular displacement, guys? S is equals to r theta. Linear velocity is r into angular velocity. Linear acceleration is r times of angular acceleration. One more time. Linear displacement, angular displacement multiplied by r. Linear velocity equal to angular velocity multiplied by r. And linear acceleration, angular acceleration multiplied by r. So in the place of s, we can write r into theta, guys. So f into r into theta whole divided by time. So force into radius is called as torque. Force into radius is called as what? Torque, guys. Torque, twisting moment. Angular displacement divided by time is called as angular velocity. So here we can write the formula torque into omega. What is the formula for angular velocity, guys? Angular velocity is equals to 2 pi n divided by 60. So what is the formula for power now? Power is equals to 2 pi nt divided by 60. Power is equals to 2 pi nt divided by 60. Let me give you a basic diagram, guys, with which we can remember all the formulas for power. Let's say it is a piston cylinder arrangement. When the piston is going to move in the backward direction due to pressure, its volume changes. Let's say it is initial volume V1 and let's say it is final volume will be equal to V2. Then what is the formula? The formula is going to become pressure into change in velocity V2 minus V1. This is the again formula for basically work done, guys, in a given time. In a given time it is going to become what? Power. So power is equals to work divided by time. Work is pressure into change in volume whole divided by time. It is P is not power, guys. P is equal to what? Pressure. Now let's say here a body is there, a fan is there which is going to rotate with certain torque and speed. Torque is given, speed is given. Then what is the power, guys? Power is equal to 2 pi nt divided by 60. And let's say here we are having certain spring. Here we are having a certain spring, guys, which is not allowing it to move in the backward direction. So spring work now. What is the formula for spring work, guys? W is equals to half into kx square. So this is also the work formula, guys, that we need to remember. Work is equals to half into kx square, where k is equals to stiffness of spring. Where k is equals to stiffness of a spring. Next one, guys, let's say this spring is connected to some gun now, and what is the power of a gun also you need to remember. What is the power of a gun, guys? Gun with which it is going to leave a bullet of kinetic energy. So what is the power formula? Work done divided by time. What is the work formula? Half into mv square of the bullet in the given time. So this can also be given in the examination, guys, that is power of gun. Power of gun. Let's write all the important units, guys, and let's complete this power concept also. What is the basic formula? What is the basic unit, guys, for power? Power is equals to 1 watt. Let's say units can be written in terms of what? Watts. Watt. What is none other than what? Joule per second. Joule per second. And we know 1 joule is equals to how many ergs, guys? In the work also, one topic itself we have discussed that 1 joule is equals to how much? 10 to the power of 7 erg per second. This we can remember. And you can write 1 HP is equals to around 746 watts, guys. Some textbooks it is given as 735 also. Try and remember any one of the value. Based upon the question you are going to change it. It can also be written in terms of 550 times of 32 feet poundal per second. Feet poundal, foot poundal per second. This is also an important unit, guys. 1 feet poundal per second is equals to 1 feet poundal per second will be equals to 4.2 into 10 to the power of 5. These are the standard values, guys, which you need to remember. 4.2 into 10 to the power of 5 ergs per second. And it can also be remembered. First of all, basic value also try to remember, guys, where 1 foot is equals to how much? 1 feet is equals to around 0.3048 meters, guys. This is also a unit that you need to remember. Try and remember all the values and important formulas, guys, which are there over the board.